When it comes to entering values in the structure category in the dowel optimizer, one of the key advantages is that most of these inputs are readily available in the project documentation. Unlike load inputs, which may require speaking with the right stakeholders or doing some targeted research, structural inputs are typically found directly in the architectural plans, geotechnical report, or material specifications. For instance, the pavement or slab thickness is usually noted in a section view of the architectural plan set. This section may also specify the support layer material located directly beneath the slab. If a joint layout is included in the drawings, it can be used to determine the joint spacing. In many cases, these values are also reiterated in other parts of the plans and specifications. In our example, a review of the plans shows a slab thickness of 8 inches, joint spacing up to 15 feet, and a support layer composed of unstabilized aggregate base. The K-value, or modulus of subgrade support, is often found in the project's geotechnical report. However, it's not uncommon to see it referenced again in other parts of the plan set or specs. If no K-value is provided, you can estimate one using a free web app developed by the American Concrete Pavement Association. While many designers default to using 100 psi per inch as a conservative input, resulting in a thicker slab section when doing a thickness design, a more conservative dowel design actually means using a higher K-value. Why? Because a higher K-value reduces the deflection basin under load, leading to fewer dowels participating in load transfer. This makes the critical dowel carry more load, so again, a higher K-value is more conservative for dowel design. That said, the K-value is one of the least sensitive inputs in the overall optimization. For more on that, refer to our video titled, "Which Factors Really Drive Dowel Performance?" Still, following the most common practice, we'll input 100 psi per inch here. Next, the concrete compressive strength is often specified in either the plan notes or material specs. A common and conservative value is 4,000 psi, which we'll use in this example. Greater shrinkage and wider joint spacing result in a larger joint opening. As joints open wider, two things happen. First, there's a reduction in the embedded depth of the dowel. And second, if the dowel has a tapered shape, then the joint opening works to reduce the width of the dowel as it enters the concrete. This impacts results for concrete bearing and shear cone as you might expect, but the smaller dowel width also means there is a reduced cross-sectional area for shear transfer, impacting the dowel shear results. Thus, the inputs of joint spacing and concrete shrinkage, which drive the joint opening, require realistic inputs for realistic results. If your material specifications include a shrinkage value, use that. For example, if a value like 450 microstrain is listed, it's acceptable and even advisable to round up to 500 microstrain to remain conservative. Even though this is a relatively sensitive variable, variations within plus or minus 100 microstrain are unlikely to significantly alter optimization results. If no concrete shrinkage value is specified, 500 microstrain is a good conservative estimate for ready-mix concrete. For a more precise input, you could also contact local ready-mix suppliers and ask for measured shrinkage values corresponding to the specified concrete strength. Once all structure inputs are populated, simply click Continue to proceed to the next step, selecting and optimizing your dowel options.